How do transistors build all digital logic? Imagine a tiny switch that can turn on and off at lightning speed. That's what a transistor does. It's the core of all digital electronics, making computers and gadgets work. Transistors act as electronic switches that control the flow of electrical current. When they are on, they allow current to pass through. When off, they block it. This on-off behavior is perfect for representing binary states of 0 and 1. In digital electronics, 0 means the switch is off, and 1 means it's on. There are two main types of transistors used in digital circuits: bipolar junction transistors or BJTs and metal oxide semiconductor field effect transistors or MOSFETs. Both have 3 terminals. For BJTs, these are the base, collector, and emitter. For MOSFETs, they are the gate, drain, and source. When voltage is applied to the base or gate, the transistor switches on, allowing current to flow between the other 2 terminals. When the voltage is low, the transistor switches off, stopping the current. Using transistors as switches, engineers build logic gates. A logic gate is a simple circuit that performs a basic logical operation. For example, a NOT gate or inverter uses one transistor. When the input is high, the transistor turns on and pulls the output low. When the input is low, the transistor turns off, and the output is pulled high through a resistor. An AND gate uses 2 transistors in series. Both transistors need to be on for the output to be high. If either transistor is off, the current can't reach the output, and it stays low. An OR gate connects 2 transistors in parallel. If either transistor is on, the output goes high. If both are off, the output remains low. More complex gates like NAND and NOR are made by combining these basic configurations. For example, a NAND gate is like an AND gate followed by a NOT gate. It uses multiple transistors arranged so that the output is low only when both inputs are high. In digital circuits, bipolar junction transistors are used in transistor-transistor logic, or TTL. These circuits include multiple transistors, resistors, and diodes to make fast, reliable logic gates. Modern electronics prefer MOSFETs because they use less power and can be made very small. CMOS technology combines pairs of P-type and N-type MOSFETs to create logic gates that consume very little power when idle. By connecting these logic gates in different ways, engineers can build any digital system. They can create simple circuits that respond to current inputs or complex systems with memory that remembers past states. Since the basic gates like AND, OR, and NOT are enough to make any logical operation, transistors are the building blocks of all digital electronics. In short, transistors build all digital logic by acting as tiny switches that turn on and off. When arranged in specific patterns, they form the fundamental logic gates that process binary information. This simple yet powerful idea is what makes modern digital devices possible.